Okay, we're in section 12 of the notes, and we're going to go through the examples now. We'll certainly work through one example at a time. We're using rules and definitions. We're trying to get familiar with rules now, all right? So the definition, certainly you should know what the definition is at this point, but we want to move towards rules. How do we get the rules through the definitions? Hopefully pay attention during the lecture, and you're making sense out of this stuff. So we'll go through some examples. Right. The intent of the examples, though, is to illustrate that we don't do every single example you could possibly have in the universe. We do some sample examples. The samples should be enough to get you going. Right. To watch someone do this, at some point you say to yourself, when do I get a chance to try? We always want you to try. It isn't like we don't want you to try. We want you to try. All right. We're going to give other examples for you to do in homework, and you should try those examples. And they should go pretty quickly. Once you understand what's going on, they really should go quickly. Do you need to reinforce what you're learning by trying? Of course you do. If you don't do that, you're going to have a real tough time, not only in this course, but any courses that follow this one, you're going to have a tough time. So I'm going to go to the whiteboard, and I'll start doing the examples. So this one over here, it's number 1. And number 1 says compute the derivative using the limit definition and the rules. I'm going to use the rule first because the rule is the easiest thing I could possibly come up with. So I think I don't have a share going on with you yet. Give me a second. Okay, I have the share going now. So the screen was, I guess I forgot to share it or something. Well, anyway, let me point out what we're doing over here. We're looking at a problem, and the problem we're looking at is f of x equals e to the pi. A lot of people misunderstand this, by the way, but I hope it's not misunderstood that e to the pi is a constant. So what's the derivative constant? The derivative is going to be 0. Let's use the rule, all right? What's the rule going to be? Limit, and this is going to be f prime of x, by the way. I'm sorry, we're using a definition. H goes to 0. F of x plus h minus f of x over h. Well, let's put this down. What's f of x plus h? It's just e to the pi. It's always e to the pi. What's f of x? It's e to the pi over h. What do you get? 0, as expected. All right, not bad. What's key say? 0. Let's do the next one. Differentiate the function. I would not do this by definition. It's an 8th degree polynomial. Could you do it by definition? Yes, but I'm just going to do this by the rule. So what do you get over here? F prime, right? I want to write down what this is over here, though. F of x is just a constant multiple of x to the 8th. So it's going to be a constant multiple, 5/4, times the derivative of x to the 8th, which is 8 times x, reduce the exponent by 1, 7. Let me simplify that. What are you going to get? 10x7. Again, I want to emphasize, please look at the k. Let's do this one over here. And again, it says using the limit definition and the rules. Well, I'm going to use the limit I'm going to use the rules first. F prime of x. What do you go there? Well, 5 times the derivative of x squared, which is 2x, minus 3 times the derivative of x, which is 1, plus 0. What does this give us? 10x minus 3. Right? Let's use the definition now. So f prime of x is equal to the limit. H goes to 0. F of x plus h minus f of x over h. Well, what's it's 5x squared, right? So let's write this down. Limit. And it's going to be 5x squared. So 5 x plus h squared minus 3 times x plus h plus 1. Oops, sorry about that. That's f of x plus h. Now I got to subtract away f of x. What's f of x? It's 5x squared minus 3x plus 1 all over h. It's work. I will get the same answer though. What do I get? I get 5x squared plus 10, excuse me, xh plus 5h squared, oh, it's going to be a long work, minus 3x minus 3h plus 1 minus 5x squared plus 3x, right? Plus 3x, yep, minus 1. Well, over h, a lot of work to do. Limit, h goes to 0. Let's look at this. Well, 5x squared disappears. That's good news. 3x disappears. That's good news. And the 1 disappears. That's good news. So what am I left off with? 10xh plus 5h squared minus 3h. And we're dividing by h. All right, let's put this down. Limit, h goes to 0. H is not 0. Whoops, sorry about that. So what do I get? I get 10x, h cancels, plus 5h minus 3. Can I do that limit? Yeah. What do I get? 10x minus 3. That was a lot of work. Do we get the same answer? Of course we do. All right. So let's take a look. And I'll go to number, I guess I'll go to number 4. All right. Now, this one says differentiated. I got to be honest with you, though, for a lot of students, they're confused by the question and they try to do something and they don't know what to do. So I'm going to point out the first thing you probably should do with this problem over here is simplify the function. Now, for some students, when they simplify something, they actually think they've done what they've been asked to do, and you have not done anything except simplify. But I want to simplify this. What do I get? 2x squared minus 5x minus 4x plus 10. And this is going to be f of x equals 2x squared minus 9x plus 10. Well, I can definitely differentiate that. I know all about those rules. So it's 2 times, that's a constant multiple away. The derivative of x squared is 2x. I'll simplify that later. Minus 9, derivative of x is 1, and derivative of 10 is 0. So what do you have here? 4x minus 9. Let's check the key and see how we did. 4x minus 9. All right, let's look at number 5. And number 5 says compute this using both the definition and the rules. Well, I'm going to do the rule first. And what do I got? I have f of x equals x to the 1/2 power. So what's f prime? It's fairly simple. It's 1/2 x to the minus 1/2, right? And let's write that a little different way. That's going to be 1 over 2 root x. If you prefer, you could write this as root x over 2x. What I do, I multiply top and bottom by root x. It's up to you. All right, I don't care. Either one's fine by me. So let's do the definition now. So f prime is equal to limit h goes to 0, f of x plus h. I think I can write that down. That's going to be root x plus h minus f of x, root x over h. I think we've seen these before. I'm going to multiply top and bottom by its conjugate. The top's conjugate, by the way. And we've seen this technique before. It's certainly following the pattern that we've seen. We get limit, h goes to 0. On bottom, you get h times the root x plus h plus root x. And on top, you're going to get x plus h. These are conjugates, by the way, minus x, like that. Well, it looks pretty simple. What do you get? Limit, h goes to 0. On top, you get h. Bottom, you get h times root x plus h plus root x. Well, h is not 0, so this cancels off to 1, and I can do the limit now. And what do you get? Limit top is 1. The limit at the bottom is root x plus root x, which is what? 1 over 2 root x. Are we getting the same answer? Of course we are. All right, of course we are. All right, of course we are. All right, let's go to the next page. I think we did okay with that one over there. Again, the reason I typed this up for you is so you have access to this if you don't want to watch me doing the chicken scratch on the side. It's so, I put the work down for it typed up. But number 6 down. Number 6 for a lot of students is going to present a nightmare. All right. The reason for that is it's got to be simplified first. I'll write this on the side for you, and I'll actually go through the simplification. The problem would work for a lot of people If they do a little bit of work, they think the job is over. No, the job is not over. You got to do the work in the beginning, which is simplification. And what do you get? X squared. And I'll go through the steps with you. I have to simplify this. What's the problem with simplification? You could make a mistake. Let's go through it carefully. We're going to use the distributive property of multiplication. X4 minus 2x cubed. I'm distributing x squared across the three terms plus 3x squared. Now I'm going to distribute minus 2x across those three terms. What are you going to get? Minus 2x cubed plus 4x squared minus 6x. Now I'm going to distribute the 3 across those three terms. What do you get? 3x squared minus 6x plus 9. Now I have to combine the terms together. What do you get? X4 minus 4x3 plus 10x squared minus 12x plus 9. Now someone says, oh, I'm done. I'll put a box on it. No, you're not done. You haven't taken the derivative. What's derivative going to be? It's going to be 4x cubed. I'm getting a little better with derivatives now. What do you get? Minus 12x squared plus 20x minus 12. Could I have made a mistake? Of course I could have made a mistake. Let's just check it. Am I getting the right answer? 4x cubed minus 12x squared plus 20x minus 12? Bingo, we got it. Let's look at number 7. Same thing. I'm going to be using simplification first. What's f of x? It's x squared minus 1 over x plus 1. The domain of this problem is all real numbers. You may wonder I'm writing this down, by the way, because I'm going to do a simplification. But x can't be minus 1. We go over here, x plus 1, x minus 1 over x plus 1. So what do I know? On the domain of this problem, f of x is identical to x minus 1. It's identical. So what's its derivative? F prime would be equal to 1. By the way, on that domain. Let's take a look at it. And what do they say? They say that f prime is equal to 1 on that domain. They're writing the domain a little differently. They're just simply saying x can't be minus 1. I'm just saying any real number except minus 1. Let's look at number 8. And again, I notice for some students it goes very quickly. I want to point out an aside, we give you little side videos. You can watch those videos if they're helpful. All right. Also, I want to point out during the, after lectures are given, videos will be posted and you can watch these at your convenience. Let's write this down. I'm going to write a little differently. What's f of x? It's 3x to the 1/2 power minus 5x. And what would that be? That would be minus 1/3, right? Let's write the derivative down. Well, that's going to be 3 times 1/2, which is 3 halves. I'm going to reduce the exponent by 1. That's minus 1/2. This is going to be plus 5/3. And I'm going to reduce that exponent by 1, which would be minus 4/3. I don't mind this answer. However, if you want to rewrite it, you can. Let's just check it. 3 halves x to the minus 1/2. 5/3 x to the minus 4/3. Yeah, I want to point out what I mean by rewriting it. Some students will write this down instead. 3, 2 root x plus 5/3. Now that's 4/3, which means x cube root of x. All right. And someone says, why would you have done that? Well, that's the way they spoke to me. That's the way I should probably answer them. But again, I don't mind that. I actually like that answer better. Let's look at number 9. And number 9, I'm looking at is f of x equals x root x. Well, it's a problem for me, so I'm going to rewrite it over here as x times x to the 1/2. This is simplification. That'd be x to the 3 halves. Let's write this down. What's f prime going to be? It's going to be 3 halves. X, reduce the exponent by 1. Well, that would be 1/2. So what do you get? 3 root x over 2. Again, mistakes happen. This is why we provide keys for you. By the way, I noticed that they have this answer down. They didn't put the root down. But again, I like the root look of it, and that's up to you if you want to write that down or not. So we did okay with that. Let's look at number 10. Number 10's, I'm going to say also for a lot of students, it's nightmarish because they don't want to do the preliminary work. I'll write this one down for you. And what do you get? F of x. I want to simplify that. And what do you get? You get 3 root x minus 5. This is the cube root of x, and they're squaring it. And this is tough, by the way. I realize that. Well, I'm going to write it, and again, I'm not saying this works or that works. The only thing that works for students is trying. And I would, spend some time trying. I'm going to write with fractional exponents though. 3x to the 1/2 minus 5x to the minus 1/3. That's not so bad, right? 3x to the 1/2 minus 5x to the minus 1/3. Right, I know it's tough. Let's take a look at it. 3 times 3 is 9. And x half times x half is x to the 1. Well, that's pretty simple. Then what do you get? Minus 15. I'm using the distributive property of multiplication. And what do you get? 1/2 minus 1/3. I'm going to put this down, but I will erase it. I hope you realize common number is 6. And what do you get there? You would get 3 minus 2, which is 1/6. As promised, I'm going to erase that. That's my baby right there on the side. Let's keep going. We have a key to look at later. I'm going to do now, I distributed this. Now I'm going to distribute this. That gives me minus 15. Well, you already did that addition, so it's 1/6. And then you get plus 25. I have to add those two exponents together. Well, minus 1/3 is minus 2/3. And I'm going to continue to simplify. Again, the problem for a lot of students when they simplify, they think they've actually done the problem, and you have not. That's my simple form of f of x. What do I want? I want f prime. What do I get? 9 minus, well, 1/6 of 30 is 5. And then you're going to take 1 from 1/6, which is minus 5/6. Minus 50/3 x. You're going to reduce the exponent by 1. So that's going to be minus 5/3. Mistakes happen. I know I said a lot to you, but please look at the answer. 9 minus 5x to minus 5/6 minus 50/3 x to the minus 5/3. Things you're working at as advertised. Let's look at a number 11. Again, we're not trying to confuse you. We're just trying to point out problems that students tend to be confused by. We're trying to remove the confusion by showing you things. This is f of x equals ax squared plus bx plus c. This is the understanding that a, b, and c are constants, and x is variable in the problem. So f prime of x is going to equal 2ax plus b. Again, a, b, and c are constants. What am I doing? The constant multiple, the derivative of x squared, which would be 2x. So that's 2ax. And then the constant multiple b times the derivative of x, which is 1. And if c is a constant, the derivative of that would be 0. All right, that answer is right over here. Let's put the next one down. And this one says differentiate the function. Well, let's write it down. So what do you get? F of x equals e to the x plus 1. Well, to be honest with you, it looks a little bizarre to me. So I need to write the way I'm familiar with it. So it's going to be e to the first power times e to the x. Well, now I do know that this is a constant multiple. E to the 1 is, by the way, e times e to the x's derivative. And what's the derivative of e to the x? That couldn't get any better. It's just e to the x. So really, what is it? Its derivative is e to the x plus 1. That's remarkable. Okay, remarkable. All right, so what do they say over here? A little tricky, by the way. It says over here, find the equation of the tangent line to the curve given blah, 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 blah. Well, they gave me the derivative. I'm not going to struggle with it. So what I want to put down is they give me f of x is e to the x minus 1 squared, and they gave me the derivative. And I'll write down for you. What's the derivative? Let me write that down for you. Again, no need to struggle. It's given, and you might as well trust them. All right, I'll trust them. They want the at the point 0. So let's write this down. So at the point 0, so x equals 0. So I have to do f of 0 to get the point, right? So what's f of 0? Well, that would be 0. That's a fairly easy to plug in. So the next thing I do is set 0. What's f prime at 0? I don't know, plug it in. So what do you get? 2, e to the 0. And then you get e to the 0 minus 1. What does that give you? Well, 2 times 1, 1 minus, oh, 0. That's pretty simple. So what do you get? My favorite form of a line is this one over here. Whoops. Y minus y1 equals m x minus x1. I'm going to use that form. It's a point slope form. Let me write that down over here. Y minus, well, the point is 0, 0, right? So y minus 0. And what's the slope? Well, this is the slope of the tangent line, m tan. It's going to be 0 times x minus 0. That's a fine answer, but to be honest with you, it looks really bizarre. So it's really saying y is equal to 0. What kind of line is that? That's a line that looks like this over here. So we did that. There's a picture. We'll look at the picture later. And it's just provided. Please indicate both. We'll do that then. So y equals 0. I see that. Let's go over here. And I want to point out, I am seeing the picture over here. And this is y equal 0. This is the point of tangent C, which is 0, 0. And this is the curve. What curve are we talking about? The curve over here. We're talking about this curve here. Now, I want to go to the next one. And the next one says, find the equation tangent line at the natural log of 2. Let's go back over here. And I'm really going to do the same thing. All right, same exact thing. So what do I get over here? I got, whoops, sorry about that. I have, whoops, sorry about that. We have x equals the natural log of 2. So my question is, what's f of the natural log of 2? I don't know. I guess I got to do it. And I see what f of x is. It's e to the x, which would be 2, minus 1 squared, which is 1. I got that. All right, so what's the point going to be? The point is going to be as follows. Let's write this down for you. ln2, comma 1. Now let's do the slope. That's going to be f prime at ln2. Well, I gotta put this down. It's going to be 2. I know the derivative because it was given to me. E to the ln2, which is 2, times e to the ln2, which is 2 minus 1. What do you go there? You get 4. What's this going to be? The slope of the tangent line. So what do you get over here? Let's write down. Y minus 1 equals, what's the slope of the tangent line? 4x minus ln 2. Right? This is okay as an answer. If you want to rewrite it, you can. Let me go through that with you. This would be 4x minus 4 ln 2. This would be y equals 4x. Well, 4 ln 2 is going to be minus the natural log 2 to the 4. 2 times 2 is 4, 8, 16, and then plus 1. By the way, I actually prefer this one over here. It's so much easier for me to read that. Let's go to the next page, and I want to point out the answer they give me, and I'll copy it. And the reason I'm doing that, I want to emphasize what we want you to do. This is I probably got it right. I can't remember what they said, yada, yada, yada. What I want to do is I want to go and I want to paste this next to my answer and see if I got it. And again, what I'm pointing out is that's what they said the answer was right over here. And I want to, get my red pen out and see if I did a good job. I see y minus 1, I see 4, and I see x minus ln 2. That's a good job. All right, let me go back and read the rest of the question. It says also you should, maybe look at the graph. We're looking at the graph, and this is the point of tangency. I'll put this down. There's a point of tangency over here. Maybe do it a different color. Point of tangency, and it looks like this over here. And that's the line. I'm not a very good line drawer there. I do okay with that. Yeah, I screwed up with the line, but anyway, the picture's there. You know what I'm gonna do? I'm just gonna erase that, all that nonsense, because it just looks awful. And I apologize. I screwed up that graph to no end. This is the line y equals 0. And this is the line Let me write down what that line is over here. Y minus 1 equals 4 x minus ln 2. I'm going to put down the points of tangency. This point over here is 0, 0. And this point of tangency over here, yeah, it's kind of hard to ballpark these things, but I'm looking at the picture. It's going to be natural log of 2, comma 1. All right. The curve, and maybe I'll put that in now. I'll do that in yellow. The curve is this one over here. Okay. So I really screwed it. That's why I redrew it. Okay. But anyway, what do you have to do now? And I can't emphasize enough times. You really have to get busy with the study department. You got to do the homework. All right. So the homework follows. I also want to point out, I will post a video of me doing your homework. All right. You should pay careful attention to what we do in classroom. At this point, you should say, when do I get to try? You get to try now. Try some of these homework problems. I would recommend doing all of them, by the way. So when you get to the exam, you won't be confused by any of the questions. By the way, that's an addition to WebAssign. If it's being assigned to you, do the WebAssign as well. Things should go very quickly, by the way. If you notice when I do these problems over here, they go quickly. And you need to get quick with this too. It isn't like, I need to be slow at this. You need to be able to do it. Okay, thank you so much. Again, if you need any additional support, please come by during office hours and I'll be more than happy to help you.